Earth is a water planet. Vast interconnected bodies of water, the oceans, cover 71% of its surface. They moderate the global climate. They fuel storms that drench the land and feed the lakes and rivers that sustain us. And now, scientists have detected whole oceans of water hidden in rocks deep inside the planet. How did our world come to be endowed with such a rich bounty? Is Earth the only oasis in space? For as long as we have gazed upon the stars, they have offered few signs that somewhere beyond our solar system are worlds as rich and diverse as our own. Recently, astronomers have been discovering planets at a rapid clip. Using orbiting observatories like NASA's Kepler Space Telescope and sophisticated ground-based telescopes. These alien worlds range from great gas giants many times the size of our Jupiter to rocky, charred remnants that burned when their parent star exploded. Some have wild elliptical orbits. They swing far out into space, then dive in close to the scorching atmospheres of their parent stars. Amid these hostile realms, a few bear hints of water or ice. Ingredients needed to nurture life as we know it. The race to find these Earth-like planets has raised anew the ancient question whether, out in the folds of our galaxy, planets like ours are abundant and life commonplace, or whether Earth is a rare Garden of Eden in a barren universe. We can begin to find out by reaching back into the history of our planet, to the particular circumstances that endowed it with its stores of water. Beyond our solar system, even in the cold blackness of space, our universe is awash in atoms and molecules. They are the raw material of the evolving cosmos, the basic building blocks of stars and planets. In some regions, a nebula may glow with an eerie light of stars. These are places where new stars and solar systems are being born. Thousands of these glowing gaseous clouds are scattered throughout the galaxy. Within their frozen interiors, atoms combine into more complex molecules. Ammonia, methane, carbon monoxide, and water. To astronomers, the presence of water, H2O, is no surprise. Oxygen, the fifth most abundant element in our universe, originates in stars that dominate many nebulae, known as red giants. Deep in their cores, high heat and pressure causes hydrogen and helium atoms to crash together to form heavier atoms like oxygen. When these stars die, they kick oxygen and other elements out into the surrounding region. About 5 billion years ago, within such a rich chemical soup, a medium-sized star, our Sun, was born. Within the swirl of gas and dust flowing into this newborn star, a solar system of planets, moons, asteroids, and comets gradually took shape. Today, you can find water in nearly every corner of our solar system. Pluto and its moon, Charon, are part of a class of small objects orbiting the outskirts of the solar system. They are leftovers from the creation of the planets. Their surfaces are lined with a thick layer of frozen methane and water ice. Further in, the blue planets, Neptune and Uranus, get their color not from water, but from methane clouds that lace their frigid atmospheres. Within them, charged particles circulate in a sea of liquid water, producing electrical currents and magnetic fields. These oceans probably resemble battery acid more than water. Within the folds of Saturn's rings are countless particles of ice. Hovering just above them is the moon Enceladus. with an icy surface that makes it one of the brightest objects in the entire solar system. The Cassini spacecraft detected a jet of water ice shooting out of its south pole. Scientists speculate that it's escaping from a liquid ocean beneath the surface. The largest planet, Jupiter, harbors its own storehouse of water. Though water exists in relatively small amounts in the giant planet's atmosphere, it helps fuel storms like the swirling Great Red Spot. Jupiter's storms are the result of water vapor rising and falling like thunderstorms on Earth. Beyond Jupiter's roiling atmosphere, beyond its volcanic first moon, Io, lies a water world, Jupiter's moon, Europa. Its bright, smooth surface is crisscrossed by channels and grooves that are thought to have been carved out by shifts in an ocean of liquid water or slushy ice that lies below. The moon likely has an inner heat source, friction from the tugging of Jupiter's gravity on its rocky core. If life forms inhabit this inner European sea, they are surely very primitive. Moving in toward the sun, the asteroids are little more than jagged cinders of rock and iron, yet they are laced with very small amounts of frozen water. Even on the hot planet Mercury, you can find ice tucked into polar craters that shield it from the sun. Likewise, spacecraft have detected ice in abundance on the lunar poles. Rocks brought back by the Apollo astronauts contain evidence that the interior of the moon may well be laden with water. Then there's Mars, at the outer edge of what scientists call the life zone. Enough solar heat reaches Mars for liquid water to flow. And from networks of ancient dry riverbeds, scientists believe that water once flowed here. And yet, today, Mars is cold and dry. In summer, dust storms scour the surface with hurricane-force winds. In winter, frozen carbon dioxide frosts the landscape. If there's any water left on Mars, it's most likely been absorbed by rocks below the surface. Venus, on the inner edge of the life zone, is similar to the Earth in size, mass, and composition. Yet its thick clouds shroud an awful reality. Clouds rain drops of sulfuric acid, not water, onto the landscape. The clouds pass some sunlight, but the thick carbon dioxide atmosphere prevents most of the heat from escaping back into space. This greenhouse effect traps enough solar energy to turn Venus into the hottest planet in the solar system. What water there is can't last. The Venus Express spacecraft found that solar winds steadily strip off lighter molecules of hydrogen and oxygen. They escape the planet on the night side, then ride solar breezes on out into space. Mars may suffer a similar fate. What makes our planet so different? For one thing, Earth is enveloped in a magnetic field generated deep in its core. It deflects the solar wind like a protective shield. Unlike Venus, water, inherited from the ancient nebula, has been able to flow on this small, rocky world since its early days. Today, water in all its forms dominates the planet. It is tied up in ice caps at the poles where it grows and shrinks with the seasons. It ebbs and flows in the oceans and in lakes and rivers, covering 3/4 of Earth's surface area. And it floats in the atmosphere in clouds of water vapor. When sunlight hits the Earth, water vapor absorbs some of the energy, holding the heat in. Another crucial ingredient in our atmosphere acts as a thermostat, a control knob to keep the climate from overheating or freezing over. The trace gas carbon dioxide absorbs enough energy to prop up global temperatures and allow water to remain in the atmosphere. But the Earth did not come gift-wrapped with this balance of CO2. In its early days, the Earth was pocked with volcanoes that released huge volumes of CO2 and other chemicals into the air. In time, some CO2 was removed by chemical reactions between rocks and water and washed into the sea. That allowed another crucial factor to come into play. Deep in the ocean, primitive life forms evolved, with the ability to take in carbon dioxide and emit oxygen in the process of photosynthesis. So it's not enough for a planet just to have water. The ability to cycle carbon in and out of the atmosphere and regulate a global climate is perhaps the highest bar that an alien planet must reach to be called Earth-like. Over the millennia, we have learned how to explore our water world. But the tools of exploration have changed, and today we are looking outward to space to search for planets like ours beyond our solar system. Are there other water worlds like our own? Do they support life, human or otherwise? A number of tantalizing hints have emerged. In studies of stars such as Kepler-6-2, 1,200 light-years from Earth. Using the Kepler Space Telescope, scientists recently detected 2 planets orbiting this star that are only slightly larger than Earth. They are both within the life zone. Do these worlds resemble Earth with its magnetic field, its climate, and its vast stores of water? Or have they gone the way of Venus, Earth's sister planet, with its dense hothouse atmosphere and barren landscapes? As we cast our gaze across the reaches of space and time, our search for life goes on. We watch for the unique signatures of a world like ours, as we scan the galaxy for another oasis in space.